Hello and welcome to our second video in capital budgeting. In this video we'll talk about internal rate of return and NPV profiles. The internal rate of return is the rate that forces all the inflows to be equal to the cost, or in other words, what is the rate that makes the NPV equal 0. So all those inflows discounted today, at what rate do they equal the cost? And remember that the NPV is the net gain in wealth obtained by undertaking this project. So in other words, the internal rate of return tells us up to what point the project begins to break even. After the project reaches internal rate of return, we get to have a positive NPV. So what is the rationale is that if the IRR is bigger than R or the WACC, then the project return is higher than the cost, which is what we want. So for example, if the WACC is 10% and the internal rate of return is 15, well, that means that there's a 5% extra return to the shareholders. So let's go to our Excel file and calculate this. To calculate internal rate of return is very easy. All you need to do is call IRR function, and it just asks you to put what are the values, the array of values. We highlight all the cash flows, including cash flow 0 this time. We close parentheses, and that's it. We can just copy this value here, and according to the internal rate of return, the project front-loaded is better than the project backloaded, which is great because the NPV also says the same thing. So that's good. Let's go back and talk a little bit more about IRR. Remember our two projects. If projects B and F are independent, we'll accept both. And if project B and F are mutually exclusive, we'll accept F because the internal rate of return of F is bigger than that of B. Note that internal rate of return does not depend on the cost of capital that we use. And here's a chart or a table that shows the NPV profile, so different NPVs at different discount rates. And what happens is that at some WACCs, at some point after 5% and before 10, project front-loaded starts to become more attractive from the point of view of NPV, while at low cost of capital, project B is the one that is attractive. So this gives us a little bit of a situation. We can chart this like this. Again, at low rates, project B is better. At high rates, project F is better. The point here is that we get different decisions depending on what the WACC is, or we get conflict. So again, the internal rate of return is only one point, the point at which the project crosses NPV of 0, 23% for F, 18% for B. When two projects are independent, no problem, NPV and IRR are exactly the same. If the IRR is greater than R and the NPV is greater than 0, we accept. Not going to be any problem. And again, if the R is bigger than the internal rate of return and NPV is negative, we reject. When we have mutually exclusive projects, the same chart becomes a lot more complicated. Well, not really more complicated, but we have this line here, this break point, in which, in this case, is about 8.7%. If the projects are on this side, on low rates of return, there's a conflict because project B is better than project F in terms of NPV, but at the other side, project F is better than project B in terms of NPV, which is what we charted here. So what do we do? How do we make a decision when they have mutually exclusive projects? The one and only tool you should use is NPV. So the punchline, follow NPV. So what are the reasons that these NPV profiles may cross? One of them is timing difference, which is what we just saw, backloaded versus front-loaded, and the other one is the size or the scale of the projects. So for an exercise, I recommend you that you calculate the NPV profiles for the cash flows on project A and project B that we have here at the bottom of the screen. Convince yourself that the same effect will take place. Our next video will be about a modified internal rate of return and payback period. Thank you.